Hi, welcome to ACE Networks tutorials. In this video, we are going to learn Spanning Tree Protocol, also known as STP, STP fundamentals. So now what is STP, why it is used, how it is used, where it is used, and what will happen if it is not used. We are going to cover all these things, all these concepts in this video. STP runs on a layer 2 device, that is your bridges and switches. That means STP is a layer 2 protocol. It is also known as IEEE 802.1d Bridge Protocol. So this is just the another name of STP. It runs on all the VLANs of a switch. That means number of VLANs equals to number of STP instances in the switch. If you got 4 VLANs, you will have 4 STP instances in the switch. The funda is very simple. Number of VLANs equals to number of broadcast domains. STP should run per broadcast domain. That means it will run per VLAN. For a layer 2 network to function properly, you should have only one active path that can exist between two end devices. For example, in this figure, we got two switches connected via two paths. One is your main path, another is your redundant path. The purpose is very simple, to provide the redundancy. But the thing is that if the main path and the redundant path, they both are active, it will cause a serious issue in your network, and it will make your network unstable and unsecure. Now let us see what will happen if you got more than one active paths or multiple paths in your layer 2 network. We are again going to consider the same topology. So now multiple active paths can cause loop in the network. Now for instance, you got these two paths as an active paths. So as we all know, switch has one broadcast domain. That means the packet received from one port will be forwarded to all the ports of the switch. So for example, switch A forwards frames to switch B. Switch B will receive the frame from port A and it will send to all other ports including the port 2. Now again, this port 2 is connected to switch A. Switch A will receive the frame from switch B. That means its own frame it is received by switch B. Switch A again by its property will forward the same packet to switch B, and this will create a loop in your network. Loops can lead to duplicate messages received by the devices. Loops can also lead to learning of same MAC address on multiple layer 2 interfaces. So because you have loop running over your network, the MAC address that was supposed to be learned by port A, now port 2 will also learn the same MAC address because of the loop. Now here comes the STP to rescue. STP is a layer 2 management protocol. STP provides path redundancy while preventing loops in your network. So this is actually the ideal thing that we are looking for in our topology. That means we should not have loops, but we should have a redundant path. So STP provides this thing. How it does that, we will just look in a moment. Now we will consider this topology, which is little bit more complex than the previous one. Here we have three switches connected in a redundant topology. That means each link has got its own redundant path. Layer 2 devices send and receive bridge protocol data unit frames, that is BPDU frames, at a regular interval. As you can see in this figure, switch 1 and switch 2, they both are exchanging BPDU frames. Similarly, between switch 3 and switch 2, BPDU frames are exchanged, and so on. So now these BPDU frames are not forwarded to the network but used to construct a loop-free path. So because of this BPDU frame, you will have your loop-free topology running in your network. STP defines a tree. Now as the name suggests, spanning tree, we know tree has roots and branches. All the branches should be connected to the root. Similarly, in spanning tree you have root device and all other switches should be connected to the root. Then STP will calculate the best path from all the devices going to the root device. So as you can see, from switch 1 to switch 2 you have this path, and from switch 2 to switch 3 you have this path. STP forces redundant data paths into a standby state. Now the paths which are not used, or the ports which are not used, STP will definitely block those ports into, it will just block those ports. If the network segment fails and we have redundant path, now for instance your active path fails and you have redundant path configured, which is right now in a standby state or in a blocked state. Now what will STP do? It will again recalculate the topology and it will make your redundant path as an active path. So now, as till now we have seen how the STP works. STP works with the help of BPDU frames. BPDU frames are very important in STP. We will see in our upcoming videos what this frame actually contains and how root device is elected and how to decide the best path going to the root device and how to decide what ports should be blocked ports, what ports should be active ports. So these all things will be covered in upcoming videos. Thank you for watching. Please don't forget to subscribe my channel. See you in my next video.